Hello ladies and gentlemen, what's up? This is Papa Bale and welcome to the channel. What we're looking at over here is what I'm generating currently off of this system. So we got this is all DC, fluctuation between 35 and 56 DC volts, and about an amp of DC current. And what we're putting in is 2.4, 0.5 volts, and in between 1 and 0.7 or 0.7 of an amp. So technically we are generating more by a lot of DC electricity. So the electricity is the same. Let's take a look at frequency is at 41 though. 42, very low frequency, very low voltage. This is what's coming off the bridge rectifier right here. I'm about to put some more juice into it. About 43 DC volts are going in, are coming out, I mean. And about 0.9, 900 milliamps. Okay, that's how much is coming out. This one's a little kind of broken, you know, so we're going to do the one that's more sturdy, and then we'll get another look at the wave here. It's a very low frequency though. We're going to turn up the wattage a little bit though. We're going to see where it starts to, we might not get that high. This is 2.7 at 1 amp. $54 DC volts, very cool. 55. $1.2. See, we're generating a lot more current with this than we would with other motors, because I'm using 20 gauge as a generator. I'm using 22 gauge, 30 gauge, 32 gauge, 26 gauge. It's all in there. Lots of iron.
Yeah, lots of it.
Yeah, lots of it. So about 55 volts of DC.
It's like it's all coming out of redstone of Hey.
So this is a 4-coil parallel circuit. So all the cardinal directions right here, north, south, east, and west, are all hooked up to this reed switch. And we're pulling between 0.5 and 0.7 right now. I want to get a tach reading real quick. Oh, we're starting to slow down. Hardcore. Maybe that's too much juice for the switch right now.
like it's all coming out of the redstone repeater.
Redstone?
Yep.
What's redstone?
That's what the wire's made out. I think.
We're speeding up. Cool. Speeding up, speeding up. So that's interesting how you increase the voltage by like 0.5 of a volt and it starts to slow down when you got all four hooked up to one reed switch.
Thanks. What are you doing?
With all that iron in there, we're getting kind of magnetically fluctuating readings. So right around 400 right now. Drop it just a little bit more. 2.6. We'll know if I'm going the right way. No. Well, I don't know yet. So I'm going to be making a motor 400. I think we're in the right direction. I'm going to be making a motor that is going to have one drive coil, and it's going to have, well, I'm going to be making two motors, maybe three motors. The first motor is going to be this one right here, but we're going to hook up the cardinal directions, and then we're going to shift it, and then we're going to hook up the other cardinal directions on parallel circuits on transistors, which should be coming pretty soon. And then when we trigger both of them at one after the other, it'll be a 4-magnet rotor. So it'll go bang, bang. That speed is going to get, it'll double up at least from
All of it's coming out of the wire.
out of a wire. That's right. That's absolutely right. It's all coming out of a wire. And then you move a magnet by it and then generate some electricity. And that's what we're doing right here.
Yeah, so so that's why the POS motor has magnets on it, or it's just for decoration.
And I mean, honestly, we are getting way more than we are putting in by a long shot. And that's probably because, I mean, we're getting 1.15, 1.16. It's still going up. I mean, we're getting like 1.1, 1.2 amps, DC amps. And we're getting about 53 volts of DC. And we're putting in 2.6 and 0.8. What you see is what you get. We'll try 2.3. We're trying to just get right around an amp, maybe 1.1. That's good. Wow, I'm so impressed. And what we have on the drive side is we got this 16 gauge, this 20 gauge, this 16 gauge, and this 16 gauge. All the 16 gauges have 250 turns, and the 20 gauge has 666 turns. This is obviously the drive coil. It has a trigger strand in it for the transistor when it gets here. And this one is the same. This one is a 20. with a 30 gauge trigger strand, but they're both in the generator cycle right now. I've hooked them both to the generator. And then this one's got 20 gauge, 22 gauge, and 30 gauge. And it's got 730 turns in it of each. And I'm thinking all this thick wire is what's giving us the more ampage here. I like how we're getting over an amp and we're putting less than one in. This one is 18,000 turns of 32 gauge. It has over a K ohms in it. This one is 26 gauge. And it's 3,333 turns. All that adds up to this over here, which is virtually a 1.1 amps and 46 DC volts.
I got one question.
Totally cool.
Why'd you call it a pulse motor?
Because you can modulate it. I think it's because you can control how fast it goes by pulsing energy to it.
Yeah.
But it virtually means that it's a sequence of on and off. It's virtually what it is. All right. So I say that's a win.
I'm back.
I'm back, he says. All right, we're putting in 3.5
Volts. Or amps.
3.5 volts, 0.6 amps. Oh, it's not working right.
Maybe you need to use a different wire, or maybe slow that down a little bit.
Yeah, I need to cut it back until we get. Maybe I need to put a resistor on each one of those to let it rev up a little bit. I'm not sure. But we've had readings between 55 and now it's at 47. But it's definitely slowed down from me messing with it. But this is all below 3 volts pretty much. I think that's awesome. So yeah, if you'd like to see more, please subscribe, hit the like button. Come on down. Peace out. Have a good day. Please subscribe. Bye now.